Okay, so now we touch on basically the time dilation conversation that was happening, but it's an extended talk on it. So basically, in 2010, scientists did an experiment. They concluded an experiment that uh, time goes faster with altitude. So the higher you go, the quicker time is for you. And they said that, well, this proves Einstein's theory that gravity slows down time. So the closer you are to Earth, the slower your time is. So they stepped it up by 12 inches. And if you go up by 12 inches, your time quickens up. You go up by 12 inches, your time quickens up. But this is gravity they're talking about. Now, they've also done scientific experiments, well, observations, where they look at stars that appear to be in one place when they're actually in another, because they actually are being seen as a result of the light emanating from them going around a large object. So gravity does change the direction of electromagnetic waves or radiation or light. So if you're measuring using these atomic clocks, which depend on radiation, yeah, if you're using if you're measuring radiation in a vacuum, yeah, and you're measuring it in 12-inch steps, so I can imagine that this is a vacuum it's quite a columnized arrangement, I would imagine, where you can go up in 12-inch steps. Now, obviously, if your measuring device is measuring the light that's going in the same direction as gravity, yeah, that light will be more intense, if you like, than if your measuring device was measuring a light that's coming across the direction of gravity, yeah, normal to the direction of gravity. So if you do a parametric study and you say, right, if we measure the atomic clock readings and our measurements are taken across the direction of gravity, and you compare that with measurements taken in the direction of gravity, and you can change the orientation and you do a proper parametric study, um, then I'm sure you will have to conclude that that does not prove that there's time dilation. All it proves is that gravity acts upon the radiation that's being emitted by the cesium atoms that you're looking at. Yeah, it doesn't prove that time has slowed down. It just proves that if you measure it in one direction, if you was to measure it across the direction of gravity, yeah, you will find that the closer you are to the surface of the earth, yeah, the um, less, well, today, sorry, the slower your time will be, and the higher you are, or the farther away from the surface of the earth you are, the quicker your time will be. Yeah, this is because if you're measuring across the direction of gravity and the light or the radiation from the cesium is skewed towards the direction of gravity, if you measure across from it, then at the bottom of it, yeah, towards the surface of the earth, you're getting less radiation, so it's gonna take you longer to reach a preset value, and at the at the top of it, or higher up, the higher you go up, yeah, you get more and more, because it's less and less concentrated as you go towards the source. Yeah, so you get the same results just by changing the direction of measurement. Yeah, and then another thing I wanted to touch on is if you look at people who live in higher altitudes, yeah, these people appear to live longer. Yeah. Why is that? I mean, studies have shown that people live longer when they live on higher altitudes. They have a lower mortality rate. Yeah. Um, so what I suggested, and I suggested this in the previous talk about time dilation, is that the higher up you go, yeah, the colder it gets, and the colder it gets, the slower decay, uh, the slower the decay process. So basically, people, if you go from the surface of the earth and you start going higher, the temperature drops. Yeah, it's like in a fridge, right? Things that are kept at low temperatures last longer. It's as if time has slowed down for them. Yeah, you can achieve time dilation without going at the speed of light just by considering temperature change. Yeah, so they've managed to come up with a clock that's a cold clock, that's in a vacuum, that's cold near absolute zero. But now they're saying that even that clock dilates. I think it loses, oh, it kind of gains 1 second every 30 million years. So it's dilating when it's stationary. What does that mean? Yeah, dilation is due to temperature change, not physical movement. Yeah, so so I would expect that the higher you are, yeah, the slower your clocks will run. Yeah, and it wasn't due to the fact that you're moving quick, it was due to the fact that you're higher up. Yeah, that's why your clocks were slower. Yeah. um Now I'm not going to go into pendulums and what happens there, where the colder it gets, the faster the clock seems to run. I'm not going to go into that because obviously the pendulum action is different from radiation or an atomic clock. Yeah. You even heard of quartz crystals, which if you're using those quartz crystals to measure your time, as the temperature drops, it changes. It slows down or quickens up. I think it's a parabola um, or concave um, kind of change. So there's a temperature where it slows down, then below that it increases or something like that. But temperature does affect your the way radiation is emitted, and if we're using radiation to determine the second, then the temperature within which that radiation is being emitted will affect what we're measuring. So back to the Mandela effect, when people realize that time has slowed down for them, yeah, time dilation hasn't been proved, but I would suggest that the reason they realize this is because they might be going through a cold patch. Not a cold patch as in emotionally, but I mean like the planet might be going through an area that is cold. Yeah. Or you might be living in an area that just had a cold snap. Yeah. Because when you're colder, time appears to be quicker than what it really is. Yeah. You could swear blind that, man, it's been an hour and it's only been like 10 minutes. Yeah. And then you start to think Mandela effect. So it is a Mandela effect in a way, because everybody who's living in that catchment, let's say there's a cold front, yeah, that comes into an area covering 100,000 people. There will be 100,000 people that believe that time's gone this quick when it's actually that much. So it is, in a way, a Mandela effect, because they'll have a large group of people who believe something to be right when it's actually not. But it's funny how nature can cause these Mandela effects, and you have to be sensitive to it. But it doesn't help to have flawed experiments. Not flawed, but I mean these are experiments that conjure up new ideas in us, so they're not flawed. Like basically experiments that claim to have proven a theory that are not infallible, if you like. So where somebody would say, I think time's going quicker, time's going slower, and then you say, well, we've proven time dilation, so it might be due to those effects, but we haven't actually proven it. Haven't proven it. Yeah, even what I'm saying now is not concrete proof. I mean, I'm thinking it's to do with temperature change. Yeah, it's just a decaying process. It's like things happen slower, but in your mind, the speed that your thoughts go at, I don't even know if anybody's ever measured that against temperature, but they've measured it against speed. But in terms of temperature, I don't think anyone has ever even conceptualized an experiment to measure how quick your thoughts go when you're in the cold compared to when you're in hot conditions. Yeah, but yeah, so to conclude, I think that experiment was very useful to say that gravity has an effect on time, but unfortunately I don't think it proved it, because you haven't actually changed the orientation. Well, I haven't seen it, but I don't think you've commented on the orientation of your measurements. I haven't seen it. Somebody post a link below before the Mandela effect changes it. Yeah, but if you just measure it at different orientations, you should get some interesting results, which might lead you to conclude that you haven't proven the time dilation effect.